In this tutorial, I'm going to take this generic level and I'm going to generate a dynamic grid over it. One that we can interact with, that will correctly show depth and all of that goodness. Hi, my name's Aaron and this is part 1 of grid-based movement with Pathfinding. In this tutorial, we're going to be creating a dynamic grid over any map we want to use. So if you want to follow along, there's a repo down below where you can download this specific project that has the finished scenes and all of the images that I'm going to be using. But you can use your own project for this. All you need is a map, is your own tile map with a couple of images, and you should be able to follow along relatively easily. Hopefully. That's the plan at least. But anyway, let's jump into it and see how we get on. Here I am in our empty scene. So if you've downloaded this, you go to start and then scenes and then the starting scene. So all it has is our tile map and nothing else. When we press play, we can't interact with it or do anything like that. Let's get started. Now the first place I want to take it to is the image folder, where we're going to focus on 2 images, and that is our selected tile and our cursor image. And I want you to notice our pivot point isn't centered. It's actually in a custom and it's slightly off on the y-axis. And the reason for that is that sometimes Unity can get confused on what needs to get layered on top of each other. When I go into our finished scene 2 here, so I'll give you a little bit of a teaser. If I click here, we see we actually have 4 images that are aligned right now if everything's centered. So we have our selected tile, we have our cursor, we have our character's pivot point, and we have this tile up here as well. All of them are on the same Z axis and same Y axis. So Unity can get a bit confused on what needs to get rendered first. It's not consistent. Sometimes it does work magically and sometimes it doesn't, and it's very frustrating when it does happen. So what I find, what I've done is just by offsetting those Y's slightly, you can kind of manually layer the tiles or the images the way you want them to go. And another way of doing this without having to do it within our image properties is do it chromatically. So when you position your images, you can kind of give them a little tiny increase. And I actually do that with the character still, because it's a pivot point based sprite. It's a bit different, but that's not for this tutorial, but I just wanted to point that out. So if you're using your own map and your own project, you can go in and change this. Let's get started. The first thing we're going to do is going to create a prefab of our overlay tile. So that is going to be within our images folder. We go to our selected tile here, which is all this is a simple square image that is going to fit over our tiles. So if I put this into our scene, I'll give it an overlay up, and you can kind of see how this is going to fit over all of our tiles and how it's going to layer across. And I've called it selected tile, but I'm going to rename it to overlay tile. I think that makes a little bit more sense now that I'm here. So overlay tile. I'm going to take this tile and we're going to do a couple of things with it. So we're going to give it a script to start with that is going to manage hiding and showing it. So let's go into our scripts folder. I'm going to create a new script. I'm going to call it overlay tile. So I'm going to take that overlay tile. I'm going to attach it to our overlay tile. We open that up. And all we need for this is we're going to create one function. For this tutorial, part of the tutorial is we're just going to create one function onto it. And all this is going to do is hide our tile. Hide and show our tile. So we're going to do void. We're going to do public, just in case we want to use this somewhere else in the future. But public void show tile. And this is going to be game object dot get component and sprite render. Hang on, everything's just a little bit messed up at the minute. Let me just try and fix myself a little bit comfortable. So sprite render dot, and to make it invisible, all we're going to do is set its alpha on its color to 0. So new color 0 0 0 0. Sorry. 1 1. We don't care about the X, Y, and Z. And this is show tile, so this is going to be a 1. And then we copy this, paste it down here. I'm going to set this to hide tile, and you're going to be a 0, just like that. And now that is this script done for now. We're going to leave the update there because we're going to use that in a way well. Now jump back into Unity. And another thing we're going to need is, because we're going to be interacting with this tile and clicking on it, we need a collider on it so we can pick up our mouse clicks. So we're going to go ahead and I'm going to add a polygon collider to our image. Polygon because it's kind of a funny shape, so square and circle isn't really going to be good enough. You want it to be accurate as possible. If we zoom in on our tiles, we can just make sure we see it properly. We can set our points to 4, and point 1 is going to be at 0 and 0.25. Point 2 is going to be at minus 0.5 and 0. Point 3 is going to be at 0 and minus 2.5, minus 0.25, and then point 4 is 0.5 and 0. And now we have our lovely diamond shape that we want. And that is our prefab that we need. So we're going to go into our prefabs folder and let's drag that overlay tile in, and we can delete that. And actually, one more thing, let's go ahead and set that to be invisible. overlay tile. Let's set that to be invisible. Wonderful. Because by default, we want them to be invisible. So that's why I'm doing that. Great. So now that we have that tile created, that's going to sit on top of our map, we can get to work on generating our grid on top of our map. So within our grid, we're going to go into scripts and we're going to create a new script. I'm going to call this map manager, and it's going to have all of our map data inside of it. Map manager, with capital M on that bad boy. Okay, and we're going to attach this to our grid class. Here in a map manager, we're going to do a couple of things. So we want this to be a singleton. So this is going to control all of our level information. So we don't need more than one of this at any point. This is going to be unique to our level every time. So to create a singleton, it's pretty simple. You just need to create a couple of static instances of this class. So this is straight out of Google, by the way, on how to actually do this. There's nothing special about it. So we're going to do private static map manager underscore instance, and then with that we do a public static map manager, and we're going to do a capital instance on this. And we don't necessarily even really need this right now for this tutorial, but this is a three-part tutorial, so this will come in handy throughout. So I'm just going to go ahead and do it now, and that's going to return our instance. So now our instance is immutable. Our singleton is immutable, which is very important. You don't want to accidentally change it at all. You want it to be solid. And we also need an awake function to instantiate our singleton. So what you want to do is you want to check if underscore instance, you want to check if it doesn't exist, or I mean if it already exists. If it already exists and it does not equal this, we're going to destroy it. This dot game object. Else we're going to set the instance to be this equals this. And that is all we're going to need to do is set this as a singleton. That's our singleton created. So now that we have a singleton created, now we got to generate our grid with the tile map. Now, because I'm attached this to our grid game object, we know our child, we have a tile map child. Now, you could obviously not put this on your grid. You can put it on something else. It's completely whatever your preference is. But anyway, for now, we're going to var tile map. Now it's going to equal game object dot. We're going to get our child component tile map. Tile map. I always put a capital for some reason. Tile map. Going to include whatever it is I need to include using Unity tile map. Then I need to get the bounds of the map. So I'm going to do bounds int. So this is basically the limits of the entire of the map is what this is going to contain. So, and that's going to call this bounds equals tile map dot cell bounds. Now what we're going to do is we're going to have three nested for loops that will loop through the entire bounds of our map, starting with Z and going down, because we want to start from our height, and then from there, once we start from the height, we don't need to get the tiles that are underneath our highest tile. So I'm going to do, as I said, we're going to do a Z. Hang on. So 4 from top down. So we're going to do Z, and this is going to equal bounds.max.Z. And it's going to go until Z is, as long as Z is greater than bounds.min.Z. Because instead of 0, because it's possible for Z's to go into the minus depending on how you draw your map. So this is a bit more reliable. And we're going to do minus on that bad boy. Okay, hang on. I did equal minus on that bad boy. Another for loop. This one is going to be Y. And for Y and X, it doesn't really matter as much. They can start from top or bottom, whatever you like. So I'm just going to put it from the bottom. Then start min.y, while Y is less than bounds.max.y. Let's keep that as plus. And then we do it, copy paste that. I'm going to put another one in. It's going to be X. Change everything to X. Let me put a little comment here. So we are looping through all of our tiles. That's what this is doing. We're looping through every single tile that we've drawn on the map. So let's capture that tile location. We're going to do var tile location, and that's going to equal a vector3 int, and that is going to be X, Y, and Z. Beautiful. Next, because sometimes maybe you have a hole in your map, we want to make sure that the tile map actually has the tile that we're looking for. So you're going to add an if in here, and we're just going to do tile map, Jesus Christ, tile map dot has tile, and all this takes is our tile location. Okay. Now that we have this set up, we can focus on creating our overlay tile. Actually creating our overlay tiles and putting them on top. So we need a couple of things here. We're going to need our prefab. So up in our top, let's go ahead and let's do a public overlay tile. We're going to call it tile prefab. We're going to call it overlay tile prefab. Then I want to have somewhere to put the tiles. I want to have a parent that can contain them in, because you're potentially creating a lot of game objects, and you don't want them just sitting in the hierarchy. So I like to have something to put them inside of. So we're going to do a public game object, and it's going to be overlay container. And now let's go into Unity. Let's create an empty game object here. I'm going to call it overlay container. Then on our grid, let's attach the container to the script. Let's attach our prefab as well. Wonderful. Now that we have those attached, let's go back in and let's instantiate our overlay tile within our container. So we're going to do var overlay tile, and that's going to equal instantiate as overlay tile prefab, and its parent is going to be our overlay tile container transform. Next, we want to get the world position of our tile location. Var cell world position, because all we have right now is a vector tree int. We want to get the vector tree of the vector version of the vector tree int. Okay, vector tree int is the grid positions on your tile map. So that's gonna be tilemap dot get cell center world tile location. Now we want to position our overlay tile to where it needs to be. So we're going to do overlay tile dot transform dot position equals, and instead of just putting it into the position, we're going to create a new vector tree, because what we need to do is we need to actually put it 1 Z higher than the tile that's on top of, so it will always render in front of it. So we're going to do cell world position dot x, cell world position dot y, and cell world position dot z +1. Okay, +1. And another thing I like to do, just to be doubly safe, is to make sure our sorting order is correct, just in case you don't have your sorting order set up correctly or not set to 0 by default. So we're going to do get component sprite render dot sorting order equals tilemap dot get component. That's going to be tilemap render dot sorting order. So now everything is on the same sorting order, the way we want to do it. I have tried before, like when I was looking up the ways of doing our sorting correctly and experimenting with different methods, I saw posts about having different elevations on different sorting orders, and I have tried that, and it just seems very restrictive on the types of levels you can create. You will start to find some nuances that there's some shapes you just can't have in your level, which I don't like. And this is, in my opinion, the best way that I've found to do it. If you have seen a better way of creating a tile map and drawing your tile map, let me know in the comments below. I'm gladly take any advice anybody has. But this is how I've done it, and I think it works quite well. So with this done, I think now we can go into Unity and actually test this a little bit and make sure that we haven't done it and made any mistakes. So when I press play, our overlay container should be filled with some game objects. Oh, I am in maximize on play. Let me disable maximize on play. And our overlay tile is we do in fact have a bunch of overlay tiles within our container. If I set it to be visible, we see our top tile here has some, is showing there. So that's great. That's fantastic. All that's left now is to let's interact with our tile map, and let's get some of that working. So let's go ahead and let's create a new game object, and let's create our cursor. Our mouse. So this is going to be our mouse, right? And let's just create a sprite render on this, and let's attach in our images folder. I'm going to get my cursor image and I'm going to attach it on. Also, similar to the selected tile, the cursor image is the exact same size as our tiles, and these lines here are just a little bit aligned with our selected tile, so it's all going to match up quite nicely. I know it's going to match up quite nicely. Within Sprite, I drew them on top of each other to know what they're going to look like on top of each other. So if you're not using my files, I recommend you do something like that as well. Just draw on top and then hide the layer, and you're guaranteed it's going to look nice. Anyway, in our cursor, we want to be able to position this lovely image on top of wherever our mouse is. So let's go ahead and let's go in here and let's give this a mouse controller script. So in our scripts folder, I'm going to create a new script called mouse controller. You might be wondering, the only reason I'm creating my scripts within this folder here is because I have all these other parts within the hierarchy, and so I have a bunch of files with the same name, so it's just a little bit easier for me to manage if I do it within here. But obviously you can create your scripts from the get add component button. It's just tidiness sake for me because this project's going to be a mess. Anyway, here we are in the mouse controller, and this is going to control all of our mouse interactions. Basically, it's going to be our controller for the game. So to start with, all we need to do is let's try to position our cursor or our mouse controller where our mouse is. And to do that, we're going to create a new script, and we are going to draw a raycast to find the tiles that we are centered on. So let's jump into that. We're going to do public, and it's going to be raycast 2D. And it's going to be an optional raycast 2D because sometimes we might not be moused on a game object or on a tile. So get focused tile, get focused on tile is a better name, I think. And let's just return null for the sake of it at the minute. And what do we need here? We need a vector 2, a vector 3, mouse position. We need to get our mouse position. So we're going to call this vector3 mouse pos. And it's going to be use our camera main dot screen to hold point. That's going to be input dot mouse position. Beautiful. And that's our kind of our world position of our mouse within the game world. But because it's a 2D game, we don't want any kind of 3D space, so we want to convert this now into a 2D object, into a 2D position. So we're going to do vector2 mouse position 2D, and that's going to equal a new vector2 mouse pos dot x and mouse pos dot y. Now that we have our 2D mouse position, we're going to draw a raycast, which is just, I guess, this imaginary line that just kind of hits things, and it will bring you back everything that line hits, is what a raycast is. So we're going to get a list of all the raycasts that our mouse hits. And the reason we're going to get a list of raycasts is because, or a list of objects that our raycast hits, is because sometimes tiles can be laid on top of each other. And as well, it's kind of inconsistent on which tile you're going to get. It might not always give you the top tile. So I like to get a list of tiles and just give me the first of that list. So we're going to do raycast hit 2D and array, and we're going to call it just hits equals physics 2D dot raycast all, and while we're doing that, we're going to use our mouse position 2D. So I'll point on the screen, and then I'm going to draw straight down, which means vector2 dot 0, that's what gives us a straight point to where we want to go. Now we need to check if we've hit a tile. So hits dot length is greater than 0. So we've hit one, and we're going to return hits, and we're going to order this by descending. If you don't know what order by descending is because I'm going to use a C# library called link, which is kind of like just this list manipulation library, which is extremely powerful and valuable, and I recommend everyone learn about it and use it. It just saves so much time coding stupid list stuff. And we're going to return our collider, or we're going to order it by collider transform dot position dot z dot first. Now within our update, what we can do is we can call that method. So we're going to do a var focused tile is going to equal get focused on tile. Let's just call this actually focused tile hit, and we want to check that we've hit something again. So if focused tile hit dot, if it has a value, now we can position our cursor with this knowledge. Let's take our raycast and get the game object of that. So we're going to do game object overlay tile. So this is what we've gotten, equals hit focused tile hit dot value dot collider dot game object, just so we don't have to do all those ifs or dots again. And now we can position this over that overlay tile. So we're going to do cursor and cursor. We're going to do this, do transform dot position equals our overlay tile dot transform dot position. We're going to position it correctly. We also want to set the sorting order correctly. So we're going to do get game object dot get component sprite render sorting order equals overlay tile get component sprite render dot sorting order. Wonderful. And that should position our mouse controller now where our tile is the tile we're focused on. We can go into our project, we'll press play, and if we move around, nothing happens because I forgot to attach the script, because of course I did. So we're going to attach our mouse controller script to our cursor object, and look at that. It is following our mouse around and focusing on the different grids, and it looks pretty good. Now there is one problem here, is that because of the way we've set up our overlay generation, is that we actually can sometimes get the tiles underneath still. So we need to find a way to stop that from happening. And it's really simple to do that. And we're going to use something that is going to be very useful for us in the future. We're going to create a dictionary that's going to store all of the overlay tiles using our grid location as the key. So if you don't know what a dictionary is, it's a key value pairing that is just fantastic for searching through lists. In this situation, our key is going to be a vector2 int, and the value is going to be an overlay tile. I want to call this map because that's what it is. It's basically our map. Then from that, because we're doing vector2 int instead of vector3 int, we can ignore the z. So we definitely only care about the top layer of our map and not the bottom layers underneath it. So down here, what we can do is map does not contain the key of we're going to store this in its own variable as well. So I guess our tile key is going to be a vector 2int, and we're going to ignore that z. So if it does not contain tile key, now we can create our map. So this is why we were going from z top down. So let's go map dot add, and it's going to be tile key. No, not you. Tile key, and overlay tile is going to be the value within it. And this is going to be extremely powerful for us throughout this tutorial. This is going to be one of our most used things, is this map. This is the whole benefit of creating a singleton instance, is that we're going to be accessing this map all the time in the future. So a very important detail is this dictionary. But thanks to this solves our problem. So if I go back in Unity, we press play, and we throw a null exception, because of course we do. Obviously this isn't going to go perfectly every time. Don't be silly, YouTube. But that is because I forgot to instantiate our map. So in our start, we're just going to do map equals new dictionary. Now I go into Unity, I press play, and I can no longer focus on that under tile that was happening before. Wonderful. Last thing now is that I just want to click and show a tile as the last bit of just interaction for this tutorial. So to do that, we're going to go into our mouse controller, and we want to capture a mouse click here. But we're going to do something a little bit lazy, honestly. If you've been on this channel before, you know I praise an event system for doing things like this, but it's a bit more complicated than I want for this tutorial. So it's a bit more learning than is needed for something like this, as simple as this. If it's something you want more of a deep dive into, I will create an event system for you in a separate tutorial. But for now, we're going to do something a little bit lazy. So I'm going to set our mouse controller to actually use late update instead of update. And then in our overlay tile, in our update, we're going to use it. So here we're going to do if, we're going to capture our mouse input. If input dot get mouse button down 0. So if we do our left click, we're going to hide the tile. So every time we click, we're hiding our tiles. But then in our mouse controller, let's copy this. In our mouse controller, down here underneath our cursor positioning, we're going to take our overlay tile. We're going to get the overlay tile component, and we're going to do show tile. And that's it. So very lazy approach to doing this, I admit, but I am aware of the time that this tutorial is going to take. So I'm trying to be as fast as possible. So I hope you don't mind. But anyway, from there, now what we can do is we can go in, we have our cursor following around, we can click, and we successfully draw on our map. And all the rendering is done correctly. And yeah, it just looks great, I think. So yeah, that's part 1 done. If you want to follow along, make sure to subscribe and like and comment and wait, because the next episode's either up or it's coming very soon. Hopefully it's going to be one day apart. So if you're here on day 1, it should be tomorrow. So yeah, cheers. See you guys. Thanks very much. Bye.